Okay, so today we're going to be looking at different types of trinomials that have an a value. Okay, and now an a value, that's going to affect how we factor it. So even though yesterday it might have seemed like we were doing the box and we always had the same factors each time, it won't be the case today. And this is why the factoring with the box is a lot better method. So we don't have to remember all this other stuff, all these different ways of doing it. We're pretty much just going to keep going the same way we're going. So the x squared term is still going to stay up front. The constant's still going to be in the back. So if we multiply those together, we get 35x squared. Now, we're looking for two factors of 35. So two factors of 35 that add up to 12 this time. So we know that 7 times 5 is 35. So 5x and 7x have to be my factors. Now, today, we're going to have to be a little more careful with our GCF, because our GCF is not just going to be x with these two terms. So now our GCF is going to be 5x. Okay, so still the same way as yesterday, so 5x times what gives me 5x squared? That's going to be x. Okay, 5x times what gives me 5x? That's going to be just 1. Okay, and then x times what gives me 7x? That's going to be 7. So my factors are x plus 1 and 5x plus 7. So by using the box, it's going to eliminate a lot of the steps we would have had to do. All this stuff up here we can pretty much ignore now and just keep going the way we've been going right now. Okay, so let's take a look at the second one. Let's go ahead and throw it right into a box and try and factor it. Okay, so 2n squared and 6 make 12n squared. Okay, two factors of 12 that add up to 7 are going to be 4n and 3n. Okay, again, a GCF of these two terms is going to be 2n times n, 2n times 2, n times 3. So factors become n plus 2, 2n plus 3. Okay, let's take a look at some of these examples on the next page. So again, let's just go ahead and jump right into our box. Okay, so we get 2x squared and 5 makes 10x squared. Okay, two multiples of 10 that add up to negative 11. This one's a little bit tricky because we know 10 times 1 adds up, 10 and 1 add up to 11, but they're going to have to both be negative to make that work. So negative 10x, negative 1x. Okay, GCF becomes 2x, 2x times x, 2x times negative 5, x times negative 1. Factors become x minus 5, 2x minus 1. Okay, same thing over here. So 5n squared and negative 3 make negative 15n squared. Two multiples of negative 15 that add up to 2 would be positive 5, negative 3. GCF is 5n, 5n times n, 5n times 1, n times negative 3. Factors are n plus 1, 5n minus 3. Okay, let's check this one. Okay, there's a negative 2x squared. There's a negative 6. If I multiply those, that makes a positive 12x squared. So even though there's a negative out front of there, it doesn't really seem to affect the box method, which is nice. So multiples of 12 that add up to 13 are 12x and 1x. Okay, GCF here is going to be 2x 2x times negative 1x, 2x times 6, negative x times negative 1 makes 1x. Factors are negative x plus 6 and 2x minus 1. Now, if we look at the bottom here, there's still going to be a couple different, there's these things called perfect square trinomials and difference of two squares. These are special patterns you can memorize if you want, but really with the box method, what's nice is we don't really have to memorize anything. So I'm just going to go ahead and go right into the box with this one. So I still start off with z squared up in front. Negative 81 is the constant. If I multiply them together, it's a negative 81 z squared. So what I'm looking for here is essentially two multiples of negative 81 that add up to 0, because there's nothing in the middle there. So that's going to be 9z and negative 9z. Okay, this is going to work out like this anytime you get a perfect square. So 81 is a perfect square because it's 9 times 9, so that's why this worked out. So GCF is z times positive 9 times negative 9. So factors are going to be z plus 9, z minus 9. Okay, the difference of two squares, so one's positive, one's negative. Okay, but again, as you kind of notice, if we're putting these into the box, we don't really have to worry about it as much. It's still working out for us okay. So 16x squared and negative 9. Okay, we might notice that 16 and 9 are perfect squares, 4 times 4 and 3 times 3. Okay, 16 times negative 9 is negative 144x squared. So two multiples of negative 144 that add up to 0 are going to be 12x and negative 12x. So again, we get those perfect squares in there. Now, GCF along the top, we have to be a little bit careful. That's going to be 4x. 4x times 4x, 4x times 3, 4x times negative 3. So my factors are going to be 4x plus 3, 4x minus 3. So what you may notice about this is example C, and you may see these shortcuts after a while. If you do, that's great, and I think it'll help you out a little. Like example C, for example, 49 we know is a perfect square, 7 and 7, minus another perfect square, which is 5. So some of you may just jump straight to saying, okay, that's 7y plus 5, 7y minus 5. Okay, if you had the box, you still would have seen the exact same thing. You still would have noticed that in there. Okay, so let's go ahead and take a look at this one too. So right off the bat, it doesn't really look like it's a perfect square, but if I take out this common factor in here, so let's look at this and see what we can pull out of it. So 45 and 80 both are factors of 5, so maybe what I might want to do is take out a 5 first. So if I factor out a 5, that leaves me with 9 minus 16m squared. Okay, with what's left there, I see 9 is a perfect square. I know 16 is, so I could say that's 3 plus 4m, 3 minus 4m. And again, if you guys aren't really seeing these patterns in here, don't worry about it. You can still throw it into a box. It's still going to factor the same exact way we've been doing it. Okay, so a couple more on here. So let's go back to the box, because that seems to be working out okay for us. Okay, so 4y squared and positive 9 makes 36x squared. Okay, two multiples of negative 36 that add up to negative 12 will be negative 6x, or negative 6y, and positive 6y. GCF is 2y. 2y times 2y, 2y times negative 3. Two y times negative 3. Okay, so what we end up with is 2y minus 3, 2y minus 3. Okay, if you're checking answers in the book, they might shorthand that a little bit and say, okay, since it's 2y minus 3 times 2y minus 3, that's 2y minus 3 squared. Okay, on a test or a quiz, either one of those is really okay with me. All right, let's take a look at the last one here. So even though there's multiple variables, let's still just go ahead and try and throw it into the box, see if it works out. Okay, so I've got 9c squared, and then I've got an s squared. Okay, if I multiply those together, that's 9c squared, s squared. Okay, ignoring the variables for a second, let's just think about two multiples of 9 that add up to 6. That's got to be 3 and 3. Okay, and really the only logical way to split up c squared would be c and c, and s squared would be s and s. Pulling out a GCF, that'll just be 3c, 3c times 3c, 3c times s, 3c times s. So 3c plus s, 3c plus s. And again, if you want to shorthand it a little bit, you could probably say 3c plus s quantity squared, because there's more than one of them.